Having trouble? Try this. Oh yeah! Our mechanism combines a Hokian straight line mechanism on this side. So if you push down on this link here, this foot pedal forms a straight line as it moves downward. This rotating this pin rotates this pin as well to the other side. This is a simple 4-barb mechanism where the foot pad here pushes up against the ground and locks in place thanks to this toggle position. As you can see, I push here, it will not move. The spring located at the toggle holds it in place due to an over-center effect. Yet we can still break the toggle by pushing up on here, and the spring helps push it back up into place and holding it in position.
For the analysis of our project, we looked at it in 2 different parts. It's 2 4-barb mechanisms, the Hokian straight line mechanism and the output foot mechanism. We looked at these separately so that we could drive equations directly from the book to complete our position, velocity, acceleration, and force analysis.
So we used the force analysis to determine the maximum force and torque applied in the system from the input link, and then we used that to determine the minimum area required to resist pin shear, pin tear out, link buckling, and the combined shear situation in the transmission pin from bending and torsion. And then using that, we determined that the transmission pin wasn't big enough, and we also determined that the links weren't thick enough.
After we decided on the dimensions and diameter of the pins, we set about construction. We ordered the parts from McMaster-Carr and set about machining the parts. We drilled the holes, laid it up with Dicom, all the basic stuff, but some of the more interesting things that we came across when we were doing construction was we found if we deployed it all the way, the link here that's in toggle might deploy too far and then we can't bring it back. And so what we did was we installed a hard stop right here. Another one of the problems was that the pins kept coming out, and so what we did was we lathed a small channel and we installed set screws onto the sides so that it would restrict side-to-side movement, but it won't restrict the rotation of the mechanism.
So we really believe our design for our doorstop is a lot more easier to use than a conventional doorstop, whether it's the hinge or the one that you saw in the beginning. We ran into some challenges along the way, such as preventing the pins from sliding out, as well as fixing 2 pins to make 1. We got around that by using set screws as well as a keyed shaft, respectively. And so yeah, we really hope you enjoyed our video.